Hello everyone, my name is Sander Vermeulen and I'm a Principal Consultant for Simulate Corporation. Today I'll be talking about the differences between spreadsheet modeling and simulation modeling. In my experience, 95% of our customers work with spreadsheet models throughout the entire organization. And that's absolutely fine because spreadsheets are readily accessible by anyone within an organization. However, spreadsheets tend to rely on a lot of assumptions, and today I'll be talking about ways to improve your accuracy in your analysis and your overall analysis capabilities by using the power of simulation. In a spreadsheet environment, you only have single cells at your availability. That means that you're stuck in using a single value if you're thinking about things like process times or arrival rates within the process. This means that you won't be able to include the real-life variability that you will see in so many processes. If you were to model a call center using spreadsheets, you would assume a flat arrival rate. However, the real process will show you that calls will come in a pretty much random pattern throughout the hour. You cannot be sure that the same process will take an equal amount of time every time it's executed. People typically apply an 85 or 90% availability of machines or people or any other resource. As a result, you may see blockages further upstream in the process or starvation further downstream in the process, which would be excluded if you were to apply a flat rate throughout your process time. Resources can represent people, machines, or anything else that can act as a constraint on your system. Typically, a single resource is allocated to multiple activities within the process. This means that when a resource is working on the first process, it will not be able to start working on a second process at the same time. This constrains the system's capability to process work, and you should include that within your analysis if you're considering to make changes to your system. Simulation offers you the capability to include resources and shifts within your model, and therefore improves the accuracy from analyzing the performance of your system. When presenting a simulation model, you can demonstrate an animated moving process map of the real system compared to demonstrating a big matrix of data or just a series of charts. In my experience, the inclusion of animation really helps people to understand the underlying concepts of modeling by looking at the animation. They're able to track individual items as they make their way from the start of the process all the way to the end of the process. This helps people to develop a better understanding of what happens within the current state of their system. It helps them to validate the simulation model, and it helps them to develop a better insight on what the future system may look like. You can see that showing an animated version of your actual processes will have a much more significant impact than presenting tables of data and charts. Typically, different products may go through different steps within the same process, as well as take a different amount of time to complete those steps. Simulation models can easily deal with this level of complexity. However, spreadsheet models typically assume the same amount of time for each of the steps, regardless of the type of job. This means that simulation models offer a much higher level of accuracy when used for analyzing the performance of your system compared to spreadsheet models. Hopefully this session will have demonstrated that the inclusion of variability, resource constraints, animation, and pathway dependency can significantly increase the capability and accuracy within your analysis. It allows us to communicate changes much more effectively throughout your organization, and we can create stakeholder buy-in before making any changes to the real system. In my experience, once organizations have seen the benefits of simulation modeling, they quickly move from spreadsheet modeling to simulation modeling. With all the great benefits we've outlined to you today, We hope you will consider using simulation for your future analysis too.